Hello, everyone. My name is Dr. Obbs. I'm one of three of the Tech Heads F1 podcast crew. And today we're going to be doing something new for you. We're going to call this a little tech bite. And it is launch season, so we're seeing a lot of new cars. And one of the most recent ones that we saw was the AMR23. The AMR23 had quite a reaction to the design of the side pod and the depth of what we like to call the water slide. So I wanted to take a little bit of time right now just to dive into what this might be doing. So disclaimer here, I don't have any of the CFD results. I don't have any of the flow data or anything like that to confirm what we're going to talk about today. But just to say that based off of my experience and knowledge and things like that, here's what I think could be happening, okay? So if we just dive right into it, then what we see with the design of the AMR23 is that we have two distinct bounding regions here on the inboard side of the car itself, and then the outboard side of what we call the water slide, which forms the water slide that you see there. It is quite a deep cut when you see it from the front and you see it from the back. You see how deep it is actually. And the outermost region of the side pod is actually here, where they have quite a thick wall of the side pod. So why would you want that? Well, first of all, side pods are there for housing cooling elements and things like that, but they also serve an aerodynamic feature. And the feature is that you use them to keep the front tire wake outboard. So outboard means away from the center line of the car. So what you would typically get is from this front tire wake structures, you would get some separated flow, and that flow would then travel downstream. These dirty flow structures will adhere to any surface. They're attracted to them like a magnet. So these dirty flow structures will want to come and to actually attach themselves to the sides of the side pod. And this is why you need to have that dividing region between the water slide cutout as well as the outboard side of the side pod. So these dirty structures are going to attach themselves to the side pod and just kind of travel down the side pod like this. Now, the reason why you have this water slide is because now what this does is it allows you to have a nice region where you can bring some clean, high energy flow down through the water slide into the rear downforce generating elements. So the rear downforce generating elements consist of a few things that we've talked about on the podcast before. The first and one of the most important, or some of the most important ones, are the beam wings. So you have the lower beam wing and the upper beam wing that you see here. This is a stacked beam wing configuration, which essentially acts like an extension of the diffuser, so we'll talk about that. And speaking of the diffuser, you also have the diffuser outline here, right? So most everybody is using the full width of the regulation box for the diffusers. And one specific thing about the diffuser to note is that when you look at the diffuser from the side, so if you're looking at the rear tire and looking at the diffuser, what you would actually see is that the diffuser slopes up like this, and then there's a bit of a curl, almost like a gurney, that happens here. Okay, so this is through the thickness. All right, so you've got a few converging flows in this scenario. So the first is that you've got all the air which is coming through the tunnels. So this is the ground effect area. And so this is the main downforce generating feature of the car, is the actual floors. So it's very important that the floors have the utmost performance because this is what's going to dictate your overall downforce predominantly. And the diffuser plays an important aspect to that. We've talked about this before in other podcasts where essentially what you're doing is as you're bringing the flow into the floor and accelerating it in the center line and the central portion of the floor, you then have to expand it evenly as it goes to the rear of the car. And so this expansion and how you do this expansion is very important to driving performance of the center section of the floor where you're generating the most amount of downforce. So as that flow is coming through this expanding region of the diffuser, it's coming out like this. And there's a region right here on the exit of the diffuser where you're going to have pressure, right? And as you climb what we call the adverse pressure gradient. So as the flow expands, you're converting dynamic pressure into static pressure, and this pressure is changing essentially the overall form of itself into essentially overall pressure, right? So as you climb and slow that velocity of the flow by expanding the volume in which it's flowing through, the pressure starts to increase, right? So it's very important with how you control that pressure expansion. Now, the exit pressure at the diffuser is just as important, because this exit pressure is going to dictate then how hard you can drive the flow through the tunnels and how large that adverse pressure gradient is that you have to climb to the exit of the diffuser. So this is then how, if we also look at a side section of the beam wing here, so typically the beam wings are pretty cranked up. They've got a pretty big camber to them like this. So maybe it looks like something like this. Yep, this is your beam wing. So you're going to get a few converging flows. So you've got then this flow which is coming through the bathtub or the water slide, which is then coming over the top of the diffuser. So it's moving up like this. And what it's doing is it's intersecting with this little curl or this gurney that you have there, which is going to cause it to upwash, right? And you naturally have this upwash effect, which is also happening from the flow as it's interacting with the beam wing. So you get this massive upwash of the flow. As you upwash this flow, what it's going to do is it's going to help you in extracting the flow out of the diffuser, which allows you to run it harder. And the other thing that it's going to do is in this region here on the bottom side of the beam wing, you're going to have then flow that's accelerating as it's moving around the curvature, the bottom side curvature of the beam wing, which means the pressure is going to reduce. So again, you're going to get a generalized region all through here where your pressure is going to be reduced, which is going to reduce the exit pressure of your diffuser, which is going to allow you to drive it much harder. It's going to make for much more efficiency through the diffuser as well. So this is really how these elements are working together. You got this curl of the diffuser, you've got the beam wings, the stacked beam wings, which are helping with that. And then you've got this nice clean flow, which is coming through the bathtub or the water slide and experiencing, it's interacting with these downforce generating elements. The other aspect I wanted to point out here is actually, if you take a look at this really cool shrouded rear suspension geometry, so the upper suspension geometry, and we can't really see the lower suspension geometry, but if you look at the upper suspension geometry, then I would guess, if I saw a section view of it from the side, that these are downwashing elements. So maybe look something like this. Which means that, again, as the flow is coming through this water slide and you're pulling all that nice clean air, it's going to interact with the upper and the lower suspension elements and the shrouding. And what that's going to do is create, again, now a downwashing effect. And the reason for that is because you do have a curvature here of the cambered shrouding profile, which the flow is going to want to stay adhered to. It's going to want to stick to. And that means that as it moves around the curvature, it's again going to accelerate. So it's going to generate just maybe a little bit of lift actually in that section right there, but it's a very small surface area. So maybe it's not so bad for the overall downforce generating elements for the rest of the car. But the biggest aspect of this downwashing suspension geometry is that it's going to also downwash the layers of the air which are around it, because the air itself has viscosity, and that air feels the influence of other layers of air around it. So as the flow is moving and adhering to the curved surface, it's going to influence the other layers of air which are above it and also pull those layers of air down. This equal and opposite forces, right, that are acting on the downforce on the shrouded suspension geometry that you have here is what's going to cause the local lift, but it's going to also create a downwashing effect. And this downwashing effect is very important because as you downwash this flow, then you then can feed more air, which is probably not the air which is coming through the water slide, maybe a little bit higher, but you're going to be able to feed more air down into the beam wings and over the top of the diffuser. So that was just a quick tech bite about the AMR23. Hopefully it makes a little bit more sense. I know my drawings were a little bit messy, but really appreciate everybody listening in. Thanks so much.